Welcome back, guys. Episode 9 is here, and you might have noticed that I kind of bounce around a little bit in the shop, and there's a couple of reasons for that. One is because that's how I roll. Another is because I like to make sure that I'm supporting the other guys on the team, the designers specifically, when they have requests that are holding them up or, limiting their ability to complete a model or an assembly or anything like that. And Bruce, my dad, is doing a verification, and he asked a couple questions, so I got sidetracked with a little bit of fun on the cockpit section and found some parts that I didn't realize were there. So I hope you enjoy this episode, guys. If you haven't, please head over to our YouTube channel and hit the subscribe button. Every subscription really does help us. Every ad that you watch on there puts a little bit of couple pennies anyway into the airworthy rebuild of Hawker Typhoon JP843 right here. So please watch the ads, please subscribe, and please hit that little bell notification there, and you'll be the first ones to be alerted when I launch a new episode on YouTube. If you're able to, please head over to our paid subscription channel too. It's a few dollars every month. You get no ads on that. You get to see everything earlier than the launch on the YouTube, and again, every penny goes directly towards us and our efforts to put JP843 back in the air. Thanks, guys. I hope you enjoy the episode. I got a phone call. Actually, I made a phone call to Bruce, my dad, and we discussed some Typhoon things today because he's doing a verification on cockpit components. And one of the things that came up was that in cross struts BB and cross struts CC, which are the main spar carry-throughs on the Typhoon, there's a number of bolts that go through to attach the end fittings to the tube themselves. And within those, when they do a lot of the tubular work on the Typhoon, there's what are called distance tubes, and that's a tube that it spans a hole that runs through the tube and through the main tube. The distance tube is placed inside, and it prevents compression of the main tube from a bolt or a rivet that's going to go into it. So in the cases of this structure, it's a very heavy structure. It's a 3-inch outside diameter tube for the spar carry-throughs. And they actually, what we found out, or what Bruce discovered, was that within this tube, there was a cast or machined fitting or a very special distance tube that was placed in there, as opposed to just a cutting of an extruded tube, which is pretty standard for all of the cockpit smaller tubes. So he picked that up through drawings and a dash line that showed up. And we actually had physical copies of these parts when we took the cockpit section apart from Roger Marley. And we hadn't noticed these. They're nearly completely apart. Some stuff is wired back onto them, but we did disassemble them. And we never took a flashlight and looked down the bore for a distance tube at the time. So it was really interesting to have this come up, and I've since just grabbed one. I believe this is cross strut CC, which is the lower spar boom cross strut on the forward spar of the Typhoon. And this one has one of these, or what we believe to be a special distance tube, and the upper cross strut, which is cross strut BB, the upper spar carry through, that one, it looks like it has two of some sort of special distance tube in it. So the two on that one relate to the two rear engine mounts for the Napier Sabre, and the one on the lower one is a support or the intersection of a V for supporting those engine mounts, but on the lower side. I found something that is really cool to see, and I'm really glad that we didn't lose it, but let's shine a flashlight down here. You can see, sort of, you can see there is a piece that crosses over in the middle, and that's this special distance tube or compressive fitting in this case, because it looks to us right now like it spans two holes from the dash line that we could see in a drawing. So I'm going to play with this. It looks like it's a bit of a tight fit, but I'm going to see if I can get it out of there, and we're going to learn about this one, and we'll go and do the same for cross-strut BB and the two that are supposed to be under where the engine mount fittings are on the Typhoon. So you can see I just grabbed a piece of 1/8 welding rod, TIG welding rod, and I bent it as a hook to see if I could drag it out. Sure enough, there's a no-go on that. But with a punch and a hammer, I was able to tap it, so there is some movement there. I only have so much movement with a punch and a hammer, and it's not the most gentle way of doing that and preserving everything really nicely. It's not going to be a serviceable part, but I'd rather just keep it in as best shape as possible as it gets removed. So my hook is in there. It doesn't really matter at the moment. We know it moves, but I think the only way to get it out of there without wrecking too much stuff is to our other fittings just about off here, and I believe it's just this one bolt and a very nice precision fit from what I recall in the other ones, and I'll be able to knock that fitting off the tube, and then I'll use a large block of wood from this end to push it out through the cross strut all the way out through this end. So one thing with all of the bolts that go through here, you see there's another row perpendicular here. They instead of having lock nuts in most locations, they're just standard nuts, and they were the bolt to lock them. The bolt was just peened over, so it's a quick, cheap. I mean, there's no parts. Knock that peen the end of the bolt over, and that nut's not going to back off of there. All of these ones we noticed when we pulled them out. These are, I believe, they're all Hawker bolts or special bolts, but they're a high tolerance bolt, and they're necked down in the middle to save weight. So they act in shear, basically, the shear of the two holes. So the hole in this pipe and the hole in this, both trying to pull away from each other, would tend to want to shear that bolt. So they're this, I believe it's a 1/2 inch diameter tolerance bolt here, then neck down to a narrower diameter, and then back open up to a 1/2 inch high tolerance down here on the outside. Tension wise, they're fairly small nuts, so there's not a lot of tension on there, and the heads are quite small on them, so all acting in shear. So to get this nut off, the first step is going to be to get rid of that the peening on the bolt. So a good question that I'm sure a lot of you are thinking is, well, that nut is absolutely trashed. Obviously the washer is pitted and corroded, it's been painted over. I've now ground down the end of the bolt, so that's toast. Why bother trying to save it all? Well, because in a lot of cases, I'm not going to go over and verify it absolutely right now. It takes a bit of digging to verify that we have that bolt. But I'm going to take it off, we'll bag it, we'll tag it. We will, just like I have here, I'll wire these parts back into the position that they sat as soon as I'm done, so that we have all the reference material that we have or that we need should anything pop up where that bolt is unknown, that nut is unknown, and we will require a spectrometer tests to find out material specifications, or we require hardness tests or anything like that. Even dimensional data, we've preserved it really nicely there. We'll pull it apart and save it just in case we need it. Might have to put some penetrant on this one. Oh, there we go. In a lot of cases, we've pulled structure apart in here, and their fits and clearances were absolutely beautiful when they produced these, and for mass production, I'm really amazed at that. There goes the washer. I even stacked them on the bench in the same order that they were, because you don't want to make that mistake. Directional information on bolts is important. There's been a lot of photos taken of this before and after, still shots, just to document disassembly. It's important to know that the bolt head actually goes through this, they call it a channel, but this bracket that's on the fork end fitting, and not the other way around. We don't want to make any difference from the way that Hawker did it. They did it for a reason, and we're not one to mess with that. There we go. Woohoo! Oh, I broke my wire there on one of the brackets. I'll put that back on. This bolt is coming out nicely. Oh, So remember I was talking about those bolts being neck down? Well, now I've got to make sure that as it comes out, because it's hanging down here, you can see that neck down section and likely corroded down in one area there. Now, so it's fallen down and I've got to knock it out. So I've got to make sure it stays true, and I'll need a punch that I can fit down into that hole and find the other end. See if we can pull that out. There we go. Didn't want it to hit the floor. So there you can see that this is that channel section. You can see that it's radiused to fit the end fitting properly. And you can see that this is that 1/2 inch diameter bolt that was going through the fitting and through the tube on the inside, all shear. And then it's neck down, probably to this thickness here. It's got some pretty good corrosion here that's reduced the diameter. But it looks to be approximately 1/4 inch there, whereas it's a 1/2 inch here, acting in shear on both ends of that bolt. So just like the nylon dies that I use for forming, this is a Cleco 4X rivet gun. And I've got a lot of these aluminum faced rivet sets too. They're another Chinese manufacturer, fairly inexpensive. They're heat treatment is pretty good on them, but they're a nice sacrificial piece of aluminum to work with when removing steel components anyway. So now that the fitting is off, I'll go back and attack the primary target of this, which was that special distance tube that's in there. Another quick inspection. Dust, that's about it. And then back in with the punch. Boy, that would hurt, hey? A long way to go. Stand by. Longer punch required. These are, I believe they're a 10-inch extension, somewhere about there, for rivet sets. So there's a female end that is a 0.401 inside diameter with the same radius, and a male end that's 0.401 outside, whatever the tolerance is that makes them fit. And I happen to have 4 of them sitting right here. So I also grabbed one of these kind of safety style flush sets, rivet sets, same shank diameter, all standard stuff, with a rubber end that's a little bit wider than the narrow thing. So I'm going to take all 4 of those extensions, I'll just tape them together, and I'll use the rivet gun with a rubberized flush set and knock that out. Hopefully that'll work. Here we go. One ridiculous punch tool. However silly it is, I'm just going to go ahead and put that on there anyway. However silly it is, you know what? I think it'll work. Don't try this at home, kids. Who does this stuff? So, safety glasses on, all the way down. Let's see. It's moving. Make sure I stay on it properly. spec stuff. Should be plopping out fairly soon. There you go, guys. That's that special cast distance tube that goes in on the bottom spar carry through. You learn something new every day. Check it out. So this is cross strut BB, and this right here is the forward side. So that forward on the aircraft, this will be your starboard side, this will be port side, and these are the feet for the Napier Sabre. That's where the engine mounts bolt into position. If I recall correctly, we stopped at this guy because that bolt wouldn't move. So this might take a little bit. It's turning my my quick stint of research into quite a bit of a project, but hopefully you guys like following along. It's kind of cool to get back into pulling apart some original structure here and seeing the insides of things that haven't been seen since the 1940s when the world was at war. Pretty tempted to get a little cheater bar on this, but doesn't seem quite necessary. So there we go. I've got penetrating oil on there now. I'll have to let it soak. There's a lot of resistance on those guys. They didn't budge. Usually you can feel it let go a little bit when you hit it with the hammer. There is nothing. And I'm pretty sure that's why that bolt's still in there. So while those ones soak, I'm going to assume that these ones are going to be just as difficult. And I'll go ahead and I'll release these two, release the washers, and get some penetrant on them. So I let cross-strut BB soak in penetrant, or at least the bolts on cross-strut BB soak. They're very stubborn, and so far there's no movement on them. Part of the reason, I think, is because of the parts that we're looking for, actually. Now, heat is another good way to take some of these stubborn bolts out, but we have to be really careful with the application of heat because it also affects temper of materials. And if there's a chance that any of these parts can be saved or reused or just used in JP843's build, we don't want to hit them with heat. So I know that the spar fittings themselves are not going to be acceptable for use for an airworthy aircraft just based on the amount of pitting on it and corrosion. You look in there, there's some pretty serious pitting. And other defects throughout, but you look at the stuff that's fallen out of it as well. These are the cross strut tube itself is DTD254 spec steel tube. It's quite clearly corroded just based on what's coming out of there. I can also see little bits of aluminum, which is alluding to the parts that we're looking to salvage out of here. So basically what I think is that there's a chance that these parts here, these brackets, these support the tubes that go down to cross strut CC, and I think that there's a chance that they could be salvaged. We'll see really upon closer inspection. I see this one has a gouge in it, so I'll have to go into the books and the drawings and really see what we're dealing with for allowances and what the dimensions of these parts are compared to what they're supposed to be from the design standpoint, and we might be able to get away with cleaning that edge up and eliminating that altogether. But long and short is that I don't want to apply heat to these parts and cause myself some issues where later on I wouldn't be able to reuse them should they be good to go. So that came off pretty well. I had to be very careful with that because I really didn't want to damage this part at all. So, and that was quite an aggressive disc, but to get that in there with a file would have been even trickier. So that all worked out well. I'm just going to clean this part up. The nuts are back on. Everything's cleaned off. It looks like we've got a nice area for the penetrant to pool around each of the bolt shanks there. I'm going to go ahead and spray it with some penetrant, and I'll give it a tap with the rivet gun again. I don't expect anything great, but we have removed a little bit of the resistance by taking those brackets off, so you never know. Might also help work some of this back in. Just the impact and vibration on the piece has potential to make things move a little bit. Movement there. Sometimes you just need a bigger hammer. Got the rivet gun, another one of my favorite rivet gun extensions. And I do that because it's got this nice opening where I can put a punch. In this case I'm using this hardened steel punch, and I'm going to use it to see if I can knock those bolts straight through. Before I get too crazy though, put my bungee back on. So when you're doing things wrong, you want to make sure you do as many right things as you can. So I'm going to also get my earmuffs on. Nothing. Well, at least there's a feel-good side. I'll show you guys. So from what I can see there is quite a bit of corrosion on those bolts. We'll have a look at them later, but right now I'm going to fight with these guys a little bit more. So without a doubt, one of my favorite punches, it's just a bolt. Taper goes a long way with big stuff like this. There's that bolt, and it's quite clear that that's going through something there. The bolt's in not too bad of shape. There is some corrosion on it. There's those two flats. Those are the pins that the Sabre sits on. I need to feel good for a bit, so I'm going to knock these other ones out. There's one more. That's 3. That one's got quite a bit of corrosion on it. That one side, it came out easier. Maybe it's because it destroyed itself. Now this guy. little more soak time on the final bolt. This is the one that Cam and I gave up on just because it wasn't really required at the time. Now it is, so she's got to come out of there. Stainless punch. You're not going to see too much other than my hand. There's nothing I can do, it's all hidden. So there's the bolt. It's actually in pretty good shape. So now I'll flip this around and I'll try and drive the punch out. Whew. Don't want to hit that. I'll see if this moves fairly easily. Whoa. So a moment of truth. It's dirty in there. Hope the camera picks that up. So it looks like there's some partial components and some that just did not make it at all. So that's our first end. We'll dump this out. As you can see, a lot's come out just removing the fitting. Another pile, primarily aluminum. It's really full in there. So clean that out and I'll see if I can free up that other end. This one's a lot tighter than the other side was, so it'll be a slow process, but I think it's moving with the rivet gun, so plug your ears. It was definitely tighter, but came off nonetheless, so you can see much better condition in there. There you go, guys. So this is what I've come up with. If it starts to bind up, I'll go to the press, but this is a piece of just stock, 4340 stock that I've got, and that's the alloy of steel, sorry. And it happens to be 2.5 inches, and the inside diameter of the cross strut is a little bit bigger. So it's not ideal, it's not really what I wanted, but it seems to work to drive them out. So I'll use the weight of this right now, and just try and knock those out. And I would expect no dirty comments from the funny farm while I do this. Gonna have a look at that. Look at that system. That's so cool. So we know that was like that, with another one in between, and one over here. That's fantastic. I'm glad to see that survived well. That's just great. All right, guys, so thanks for watching. We've got parts that I didn't know were in there. Distance tubes are one thing, but what they call these is distance blocks, and there's not too many around, but there's cross-strut BB, cross-strut CC, as I've shown you here, and cross-strut KK, which is the lower rear spar carry-through, has another one of these, and what we believe is that it has a third bolt location added onto it. So I'm going to save you the pain of watching another one being extracted from a tube. The process will go very much the same, but we'll get all of these out. We'll get the data confirmed, written down, and off to Bruce for work in the model work, and hopefully be able to produce some of these guys for the cross struts that we've got for our cockpit section here. So pretty neat stuff. I was really excited to see that come out like that. Anyway, thanks for watching, guys. Next episode's coming up fairly soon. Episode 10, we're going to hit the double digits with it. And likely the one that I'm going to publish, I'm still working on here, is about propellers and some of the propeller shenanigans that we go through here, and it's an ongoing situation. So it'll be pretty cool to share some of the details with that with you guys. And again, please subscribe to our YouTube channel and our paid channel if you can. It all helps us out, and together we'll be able to get Hawker Typhoon JP843 back in the air where she belongs. Thank you so much, guys. We'll see you soon.